Good morning, everyone. Our project is entitled Experimental Investigation of Relationship between the number of coil turns and the strength of electromagnet. So, electromagnet are devices that produce a magnetic field when the electric current flows through a coil of wire. Unlike a permanent magnet, they can be switched on and also switched off by controlling the electric current. The objective of this project is to investigate how the number of coil turns influence the strength of electromagnet. So our hypothesis is that increasing of the number of turns in the coil will produce a stronger magnetic field, allowing the electromagnet to lift more paper clips. This experiment is based on the principle of magnetostatic field and Ampere's circuit law, where the magnetic field generated by coil is directly related to the number of turns and the current flowing through it.
The theoretical foundation of this experiment is that an electric current flowing through a conductor generates a magnetic field around it. When the conductor is wound around a coil, around the iron core, the magnetic field produced by each turn combines and reinforces one another.
Next, I will begin with the experimental procedure and data collections. Since this experiment was conducted using a systematic procedure, first, the copper wire was wound tightly around the iron nail according to the required number of turns. The end of the wire then connected to the battery through a switch. Once the circuit was completed, electrical current flowed through the coil and magnetized the iron nail. The energized electromagnet was slowly lowered onto a pile of identical paper clips before being lifted vertically. The number of paper clips successfully lifted was recorded. To improve the reliability of the result, each coil configuration was tested 5 times. The average value from the 5 trials was then calculated. The collected data were organized into table and plot into a graph showing the relationship between the number of coil turns and the average lifting capacity of the electromagnet.
The experimental results show a clear increasing trend between the number of coil turns and the lifting capability of the electromagnet. As the number of turns increase from the 50 to 150, the average number of paper clips lift also increased significantly. This supports our original hypothesis that increasing the number of coil turns strengthens the magnetic field. This observation agrees with the electromagnetic theory because each additional loop contributes to the overall magnetic field generated by the coil.
In conclusion, the project successfully demonstrates the relationship between the number of coil turns and strength of an electromagnet. The result clearly indicates that increasing the number of turns increases the magnetic field produced by the coil, resulting in greater lifting capability. This experiment also verified the fundamental concept of magnetostatic field and Ampere's circuit law learned in class while providing practical insight into the operation of real-world electromagnetic devices. Although some experimental limitations existed, the overall trend strongly supports our hypothesis and align well with established electromagnetic theory. Thank you for your attention. We hope this presentation has provided a better understanding of how electromagnet work and how coil design affect their performance. Thank you.